Right now, as you're watching this, Earth could be falling into a black hole, and you'd have absolutely no idea. Not tomorrow, not next year, right now. Here's the part that should terrify you. By the time you felt anything, it would already be too late to even scream. Welcome back to What If Lab. Today we're diving past the point of no return, and by the end, you may never trust the night sky again. Let's keep it simple. A black hole forms when a massive star collapses under its own gravity, becoming so dense that light itself can't escape. Around it, an invisible boundary called the event horizon. Cross it, and you're not coming back. Ever. Now imagine a rogue black hole, wandering space alone. No countdown, no Hollywood explosion, just gliding toward us. And here's what makes it cruel. You can't see it coming. It's literally invisible. The closest known black hole is 1,600 light years away. But what if I told you that even if it was right next door, the very fabric of space-time itself would betray you first? Advanced physics calls this gravitational time distortion, where space and time twist in ways that would make your head spin. As it gets closer, something strange happens. From far away, say, if your friend was watching from Mars, time near Earth appears to slow down. You'd look like a glitch in a video game, moving frame by frame. But to you, time feels completely normal. You'd be living your last seconds while they watch you freeze forever. That's gravitational time dilation. Intense gravity literally warps time itself. The stronger the gravity, the slower time moves. Then the real damage begins. Not ocean tides. Spaghettification. Yes, that's the real scientific term. The black hole's gravity pulls harder on the side facing it than the far side. The Pacific Ocean would levitate. The Rocky Mountains would pancake like wet cardboard. And you'd be stretched taller than a skyscraper. Not dead yet, just longer. NASA calls it the worst way to die that we can mathematically prove. Physics calls it Tuesday. And from an advanced standpoint, tidal forces at this scale are enough to literally shred atoms, a process that classical physics can only approximate. Here's where your brain breaks. If you were falling in, crossing the event horizon wouldn't feel special. No flash, no pain, no dramatic whoosh. You'd just keep falling, completely unaware you crossed the point of no return. Meanwhile, from far away, you'd appear frozen at the edge forever. That's gravitational redshift. Light loses energy trying to escape, stretching until you look frozen in time. You'd finally win at cosmic freeze tag by dying. So which version is real? The you that falls or the you that freezes? Physics says both. Welcome to general relativity. Inside, there's no turning back. Stephen Hawking proved you'd eventually hit the singularity, a point of infinite density where Earth, humanity, and all of history get compressed smaller than an atom. Laws of physics break down, which is science speak for, we have no idea what happens next. Advanced theoretical models even suggest space-time itself could ripple violently at that point, creating conditions no human mind can truly imagine. Some theories get stranger. The holographic principle suggests all your atoms, memories, even your embarrassing Instagram posts from 2014 could be stored on the event horizon forever, like a cosmic hard drive. You'd be gone, but your information lives on. Imagine your most awkward selfies preserved for eternity. Yikes. And the wildest possibility? Black holes might be gateways. Not just to another place in our universe, but other universes entirely. No proof. No return ticket. But maybe Earth isn't destroyed. Just relocated. Exciting. Until you realize there's absolutely no coming back. No messages home. No rescue mission. Just elsewhere. If you're hoping for a happy ending, physics doesn't do happy endings. It does endings. Here's a mind bender. What if this already happened? What if Earth fell into a black hole millions of years ago, and everything you think you're experiencing, your coffee, this video, your plans, is just information encoded on that boundary? Reality would look exactly like this. Normal, stable, familiar, uncomfortably normal. Advanced simulations suggest such encoding would preserve the universe in a 2D projection, a cosmic illusion we can never fully verify. Should we actually worry? Probably not. The closest known black hole is 1,600 light-years away. At its speed, it would take longer than the age of the universe to reach us. Scientists hunt for smaller rogue black holes, but so far, nothing dangerous has appeared. Still, the universe has a lot of hiding places. Rogue black holes, estimated 100 million in our Milky Way alone, silent, invisible, patient, basically the ultimate cosmic ninja,